So what's the big deal about slope? Is that what you're thinking right now? If you've just been introduced to slope and you want it to be simplified, then you're in the right place. I've created a handout for you to follow along with, so you can download it here below in the description, print it out and fill it in with me so we can simplify slope and have it all cleared out for you going forward. Hi there, my name's Danielle and I'm a high school math teacher. And if you're new here, I teach math strategies to math students so they can learn math with ease. So definitely hit subscribe below so you can keep up to date on my new and upcoming videos. So many of you might be thinking, why do we even need slope? What's the purpose? And slope is actually a pretty big deal. Despite you needing it as you progress through the levels of math and make your way to calculus, where the essence of calculus is based off of slope, it's pretty practical in our day-to-day lives. You will probably get a paycheck at some point in your life. And if you're paid hourly, your $15 an hour, your $20 an hour is considered a rate of change, which is slope. And we're going to talk about that. If you think about the steepness of a line, that is slope. And if you've ever seen these signs on the roads, you'll know that you are heading onto a road with a very steep slope. And that actually happened to me once in the winter when it was very icy and our car almost didn't make it down a sloped hill of only 10%. You wouldn't think it's that crazy, but when there's ice on the road, it's pretty steep and slippery. So if you have that handout ready and it's printed and ready to go, come join me now and let's make slope simplified for you. Okay, so here we are with the handout. And what I always like to start with is the equation or the idea that we're building up to. So up here at the top, this is actually, even though we're going to focus on slope of a line, it's going to be useful because it's going to play a big role in the equation of a line. Y equals mx plus b. Okay, so I'm going to go through all the variables right now and what they mean. Y represents all the y values on a line. So if we're looking at just any line on the graph, it has ordered pairs, and each ordered pair has an x and a y value to it. So the y just represents any y value that could be on this line. M is the steepness of this line. We call it slope. So how steep is this? X are the, there's a typo here, X values on the line. So same idea, all the X values that are possible on this line. And B is the initial value or the y-intercept. This would be considered the big dot here, the y-intercept, because it's crossing the y-axis. Okay. Now this slope is going to be positive because it rises to the right. If we were to get a line that falls to the right, it would be considered a negative slope. And you'll see that come through in our calculations. All right. So the key idea here is slope M is equal to rise over run, or rise divided by run. It's a ratio that compares the rise to the run. So in this simple diagram, I created a line that passes through horizontally. It goes from 0 to 6. So it has a run of 6 units. That measures the horizontal distance. This line, the diagonal line, rises vertically 5 units. And that's, like I said, measuring the vertical distance. So therefore, the slope of this line M is going to be the rise over the run, also known as the change in y divided by the change in x. The reason for that is from 0 to 6, we've changed 6 units, positive 6 units, because we went to the right. Here, we changed vertically 5 units, positive, because we went vertically up. So here, we would write our slope is 5 divided by 6. And of course, if these numbers could be reduced, we would reduce them. So let's look at an example together here, where it's not so crystal clear on what the slope is, like the example above. If you are given a line, the first thing you want to do, and I can't stress this enough, is find 2 clean points. What do I mean by that? I mean that, and I hope you're copying this down, that you are looking for 2 points on the graph that have whole numbers as their x and their y. No decimal values here. So if I were to pick, for example, and I'm going to erase this soon, don't copy it. If I were to pick this value, it would be a decimal and it wouldn't be as accurate because we're estimating that decimal. So let's get rid of that. And let's work with the nice clean numbers of 2 and 5 and -1 and 2. What we want to do is draw a horizontal line going across, and mine's not going to be straight because I'm not using a ruler, but I hope you are. And you're going to stop right underneath the next point. Then you're going to draw a vertical line. I'm just going to go from up here because it's easier on my device. Because I can't use a ruler and I want to show it in action. So you're creating a right angle triangle, 90 degrees. This is called a rate triangle. Okay, so after you get your 2 clean points, you want to create a rate triangle. From there, we can then count the run and we can count the rise. This is the most basic way to get slope of a line. So if I count how many square units I'm going over, I've moved 1, 2, and I'm paying attention to the scale here, because if this was scaled by 2, I'd be counting this as 2, 4, 6. But this is 1, 2, 3 units, positive 3 units to the right. How about our run? That was our run. How about our rise? Our rise is 1, 2, 3, 4, 5, 6, 7 units, positive because we went up. So 7 units up. So then what we can say is M is equal to rise over run, which is equal to, now the rise is 7 and the run is 3. Fantastic. What I want to show you next is how to do this with a formula, because the formula will come in handy at different points as we progress to higher levels of math. So let's work through this in a different color. So the slope formula, let's see if I could put it here, is M is equal to Y2 take away Y1. And I know you're thinking, what does this mean? All divided by X2 divided by X1. Okay. Now this is part of the idea of rise divided by run, or the change in Y divided by the change in X. Another way we could write this actually, and I'll put it here, is delta Y. Whoops. Let's rewrite that. So it fits on the page. Delta Y divided by delta X. In science, that just means the change in Y divided by the change in X. Now we already know we're supposed to get 7 over 3 because we're just smart like that. But let's see why. What does this Y2 and this Y1 mean? Well, what I'm going to do is I'm going to label these 2 points. I'm going to call this X1. This is subscript 1 if you can see it, and Y1. Then I'm going to call this my second point, X2, Y2. So what does this mean? Okay, let's look at the Y values first. The Y value, Y1, is equal to -2. The second Y value, Y2, is equal to 5. Now, if I were to just put the Y1, if I just shifted here, Y1 is equal to -2. What would be the difference between 5 and -2? Well, we would just do either in our heads or like how we counted squares, we would say 5 take away -2. And that would give us, I'm going to ignore the X's for a second, our +7. So it matches. Now, let me change colors again. For the run, we have X1, oh, I like this yellow, is -1. And our X2, I'll put it down here just because we're going across. Our X2 is here, it's 2. So X2 is equal to 2. So if we want to find the difference between these two, we're going to subtract them. We're going to take our X2 and do 2 take away -1. And that's going to become +3. And lo and behold, we have the same slope. Now, what you might be asking me is, does it matter if I call this X1 and Y1 and this X2 and Y2, or could I switch them around? That is an amazing question. So what I'm going to show you on the next page is actually doing that. If we called them, what if we labeled them differently? So originally 2 and 5 were our X2 and our Y2. I'm going to now call this X1, Y1. Here, I'm going to call this X2, Y2. So the slope formula, writing it out with me, always write out your formulas. Y2 take away Y1 divided by X2 take away X1. So if we do this properly, Y2 is assigned a value of -2 from up above. Subtract Y1, which is 5, divided by X2, which is -1. Subtract X1, which is 2. So -2 minus 5 is -7. And -1 take away 2 is -3. Uh-oh. Wait a second. Didn't we get +7 over 3? But by simplifying 2 negatives when they divide, become +7 over 3 anyways. So that just goes to show that it doesn't matter which way you order the points. What does matter is if this becomes X1, this has to become Y1. You cannot label this Y2, okay? Now, where are we going to use this number? Well, remember, I was telling you that Y equals mx plus b is the equation of a line. Well, now we know the value of m. Y is going to be 7 over 3 x plus b. And soon enough, we'll be able to figure out b algebraically, just like we figured out slope of this line algebraically. Can we take a sneak peek up above and see it up here? It should be something below 1. So we're assuming it's going to have a y value of, I don't know, maybe 0.2, 0.3. I'm just estimating, right? But once we figure it out, we'll put it right there. And that would be our equation to a line. So there you have it, slope of a line. You have 3 ways you can look at it and 2 ways that you can solve it using a right triangle and your slope equation. If you have any questions, you can just put them down below in the comments. And I hope to see you in the next video where I tackle horizontal and vertical lines and their unique slopes. Bye for now.